Hi students, welcome to Code Pathshala. Today we will be solving the subsets problem on LeetCode. Let's look at the problem statement. The problem statement says we are given an integer array nums of unique elements and we have to return all possible subsets. So given an array of numbers with unique numbers, we have to return the possible subsets. The solution set must not contain duplicate subsets. So the solution should not have any duplicate subsets, but you can return it in any order. Okay. For example, if the 1, 2 is a subset, we shouldn't be returning 1, 2 and 2, 1. Only one of them should exist. Okay. So given example 1, 2, 3, the possible subsets are empty set. Each of the numbers 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. If it is just one element, it would be empty set and the element. Okay. So let's look at how we can solve this. First of all, given a number, what are the possible subsets that we can form? Okay. So if it is empty set, that empty input. If the input is empty set, then the subsets are there will be only empty set. If the input is, let's say, just single number, then the possible subsets are empty set and the number itself. If the given input is 1, 2, the possible subsets are empty set 1, 2, and 1, 2. So every possibility, we will be getting 2 power n possible subsets. So here n equal to 0. So 2 power 0, we get 1 subsets. Here n equal to 1. So we get 2 subsets. Here n equal to 2, we get 4 subsets. So similarly, in our answer, so the maximum number of subsets would always be 2 power n. We know this. Now, how do we find the subsets? So 2 power n is a number. For example, let's take this example of given numbers is 5, 6, and 7. Okay. So there are 3 numbers in the set. Given this number, we have 2 power n, which is 2 cube. In this case, we'll have 8 possible sets. So let's represent binary values of the numbers from 0 to n 2 power n minus 1. Okay. 0 is all zeros. 1 is 0, 0, 1. 2 is 0, 1, 0. Okay. 3, 0, 1, 1. 4, 1, 0, 0. 5, 1, 0, 1. 6, 1, 1, 0. And 7 is all ones. So these are the numbers we have. Now, if we think of these numbers as 0 is saying the number is not part of the subset, and 1 is saying the number is part of the subset, then this bit representation actually represents all our subsets. Okay. Now, look at the numbers in the reverse order because this is 0th bit. So this position represents 5. Okay. This position represents 6. This position represents 7. Okay. So here for this, we are saying the subset is empty. For this, we are saying subset is 5. For this, subset is 6. For this, we are saying subset is 6 and 7. Okay. For this, it is just 7. Okay. This is 5 and 7. Okay. This is 6 and 7. Okay. This one is 5 and 6. Okay. 0th bit represents 5. First bit represents 6. Second bit represents 7 and so on. Okay. So that is why this is 6 and 7. This one represents all of them, 5, 6 and 7. So with a simple bit representation, we can find all the subsets. Okay. So this is the simple funda we will use. Now before we code, how do we, so that means at every point we can traverse from 0 to 2 power n minus 1 and figure out what are the bits set and take that to our subset. So how do we figure out if a bit at kth position is set? For example, if our input is 101 and how do we derive that to 517? Okay. So initially we will look at this number. So we have to check whether this bit is set. Okay, this is at 0th position. Then we have to check if this bit is set. Then we have to check if this bit is set. How do you check if a bit is set? So let's say a bit at kth position is set. How do we check? You left shift 1 by 1 k times and AND it with the original number. Okay. If this is not equal to 0, that means bit is set. That particular bit is set. Okay. So let's do that operation for 101. So we are saying our number is 101 and we are checking, let's say if bit at position 1 is set. Okay. 101 and 1 less than 1. So 1 less than 1 left shift by 1 basically. What this will be 101 and 10. Okay. So now if you do this, what will happen? 101 and 10. 0, 0, 1. No. This is also 0, right? So 0, 0, 0. So it is all zeros. So bit at this position is not set. Let's take another example. Let's still say our number is 101 and we are checking if bit at position 2 is set. That means we have to left shift 2 times. Okay. When you left shift 2 times, what happens to this? 100. Okay. Your number is 101, 100. Okay. 1 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1. This is not equal to 0, which is why the bit at position 2 is set. Okay, let's look at another example. Bit at position 0. This means your left shift by 0 means you are not shifting anything. So essentially your number would be 001. 001 and 101, 111, 0 and 0, 0 and 0. So it is still not equal to 0. So at position 0, the bit is set. Okay. Position 0 is this one. Position 1, position 2. Okay. So you left shift a number by those many places and AND it with the original number. That's how you will figure out if a bit at that position is set. We will use this to compute the subset. Okay. Now let's write code for it. Okay. So initially we need a array list to hold the result. Okay. Result we want is list of lists. Okay. Let's say result is new array list or any list per se. Okay. Then let's take n as the number of elements. Okay. And let's also find number of subsets possible. What did we say? The number of subsets possible were 2 power n. And how do you do 2 power n? You can use math.power of 2 comma n, or you can just left shift 1 by n times. This will also give you 2 power n. Okay. Then for int I equal to 0, we have to find these many subsets, right? Number of subsets I plus plus. So at each point we have to find the subset. Let's first define a empty subset. Okay. So initially it is empty. Now based on the bits that are set in I. Okay. So here each of these, sorry, each of these numbers represent our I value. In iteration 0, I is 0. Iteration 1, I is 1, etc. So we have to find which bit is set in I. Okay. And add that number to the subset. Okay. So to figure that out, we have to, so I will have n bits, right? N is the size of the number because we did 2 power n for I. So for int j equal to 0, j less than n, j plus plus. Okay. For all the numbers in this, we are checking if that particular number's bit is set in I. How do we check if a bit is set in I? We have to do I and which bit are we looking for? Whatever the value is for j. We are checking if number at position j is should be added to subset or not. So that is decided based on the bit value of I. If in I binary representation, if the bit at number j is set, that means we have to add it to the subset. Okay, that is found by using this bitwise operation. So what we are doing here is we are checking if I has a bit set at position j. If that is the case, we add that element to the subset. Okay. So we traverse this for all the whole of numbers, and for each number we'll check if that is set in the I or not. If it is set, we'll add it to the subset. So end of it, we will have the proper subset defined. We will add it to the result. Okay. We just have to return this result. All right. Okay. We missed one brace maybe. Yeah. Let's submit this. So for each number in the total number of subsets possible, each number represents a subset for us. Each number. I is 0, 1, 2, 3, 4, 5, 6, 7, and so on. So for each number, the J loop, what it is doing is it is checking if any particular bit position is set or not. If it is set, it is adding it to the subset. And finally, we add that to the result. Okay. So it ran in 0 milliseconds. So what is the time complexity of this? So this one is taking, it is 2 power n. Number of subsets is 2 power n, right? And we are running that n times. So the time complexity is n into 2 power n. Okay. Space complexity also, if you consider the result array, it would be same, n into 2 power n. If you don't consider that, it would be empty or order of 1. Okay. Hope you understood the problem. This is a very good application of the bit operations. So if you understand this fully, you can write clean, clear code like this. So do practice bit operations. They are definitely helpful in many problems. Thanks for joining.